physicists have formulated a new model that could solve 5 of the universe's biggest mysteries. The model, known as SMASH, is a minimal extension of the standard model, adding just 6 particles to account for inflation, dark matter, baryogenesis, neutrino oscillations, and the strong CP problem. While earlier efforts have attempted to explain these phenomena by much more complicated means, even adding hundreds of particles, the researchers say their method shows that the problems can be intertwined in a remarkably simple way. The standard model axion seesaw Higgs portal inflation model adds 3 neutrinos, a fermion, and a new field to the standard model. According to New Scientist, this field contains just 2 particles. The axion, a dark matter candidate, and the inflation SMASH fills the gaps in the standard model, which has been unable to address a number of long-standing problems in physics, the researchers explain in a paper published to RZIF. One such problem is the evidence of yet unidentified dark matter, which makes up nearly 26% of the universe. The authors note, along with this, it is still unknown why there is an imbalance between matter and antimatter, and the mechanisms behind primordial inflation remain a mystery. And, on top of the problems at the interface between particle physics and cosmology, the standard model also fails to explain issues of intrinsic naturalness. The researchers explain, these include the nature of neutrinos and the strong CP problem, which addresses the asymmetry of the universe, combined with a cosmological constant to account for the present acceleration of the universe. The SMASH model offers a self-contained description of particle physics from the electroweak scale to the Planck scale, and of cosmology from inflation until today. The authors write, the model predicts that the axion should be roughly 10 billion times lighter than the electron, and the researchers say their theory can be tested in the foreseeable future. Unlike many other models which must wait decades before they are checked, particles this small could be investigated with the Koltask experiment in South Korea, the proposed Orpheus experiment in the US, and the planned MADMEX experiment in Germany. According to New Scientist, the best thing about the theory is that it can be tested or checked within the next 10 years or so. Co-author Andreas Ringwald at the German Electron Synchrotron (DESY) in Hamburg told New Scientist, you can always invent new theories, but if they can only be tested in 100 years or never, then this is not real science but meta-science.